The surging energy and initiative of the 20th century have made it the most productive in history. The impact of rapid expansion upon government, financial and industrial institutions, and other elements of business life has been tremendous. Problems of business management continue to increase in volume and complexity. Business executives know that their first duty is to operate on sound business principles. Frequently, they lack facts for decision, isolated for action, not buried in voluminous documents, extensive reference records, and incomplete reports. Knowledge of vital operations that could reveal opportunities to reduce expenses, to develop new products, to create new markets. Management needs timely facts, today's facts, to properly employ resources, capital, and manpower. Data recorded on a myriad of sizes and shapes of paper are the facts concerning a company's day-to-day operations in serving its customers. This paperwork is generated by the multiplicity of transactions involved in the lives of more than 160 million people. This data from many sources must be processed and reprocessed to produce as output essential business results. Isolating organized facts, facts that are vital to management in operating a business. But as business has expanded, the mountain of data and the myriad of clerical steps have multiplied, clogging lines of communication and presenting a massive processing chore. This is the documentary evidence of modern business growth. What is needed is a way of shearing through the organized confusion and fabulously extensive reference data to the vital core of fact. What is needed is a shortcut, a direct line to decision for business. Progress in office mechanization has come through punched cards, giving life to inert data. Information recorded once may be processed automatically. These machines designed to aid business fill a definite need, and so have become universally accepted, compiling data more quickly and accurately than otherwise possible. But now, an even more direct line to decision is available for business and industry. A new concept, electronic data processing machines. The first of these is the Type 650 magnetic drum data processing machine. It offers every IBM punched card user more capacity, fewer operations, and less handling of data. Its IBM magnetic drum, a relatively simple memory device, stores procedure instructions and data on its surface in the form of magnetized spots. The large memory of the drum permits the storing of program procedure instructions, current data, year-to-date records, account distributions, information such as rate tables, which may be referred to during processing. All information stored here is available for processing in a few thousandths of a second. The drum in operation revolves at 5 times the speed of an airplane propeller. Punched card records for a multiplicity of accounting operations are completed in a single machine step. The 650, with its easily accomplished stored programming, can be an end in itself in answering the problems of business, or a first step into more powerful electronic data processing systems. To meet the unprecedented demand, IBM is producing these machines in volume at the plant in Endicott, New York. 1953 and 1954, IBM produced Type 701 electronic data processing machines to aid the defense effort and make America stronger by solving problems in atomic research, jet engine design, and guided missiles, as well as other secret defense projects. These machines were produced on the world's first production line of electronic joyants. One 701 user has determined that the work he is doing on his machine would require 6,000 trained men with desk calculators, an impossible situation. His present costs are less than the depreciation on the desk calculators alone. Although used primarily for defense, the 701 is solving many peacetime problems, like those concerned with commercial airliners. Before an airplane can fly commercially, it must have a certificate of approval from the Civil Aeronautics Authority. Many calculations are required to determine performance characteristics of the airplane before application for approval can be made. These used to require many months. The 701 did them all in 1 hour and 18 minutes. The DC-7 was flying in coast-to-coast non-stop commercial service 4 to 6 months sooner than would have been possible without the 701. Yes, the 701 supplied a direct line to decision for engineering problems. Tremendous experience in the engineering, servicing, and operation of electronic data processing equipment has been acquired. The components and techniques have been proved. And now they are being applied to the many problems of business and commercial life. In this area so familiar to management, the growing complexities cry out for a new perspective. Here is management's newest and most powerful instrument for business. Decades of experience in business procedures and data processing are behind this answer to the volume, input, processing, and output requirements of commercial life. Input of information may be by card readers, which feed data or instructions on punched cards directly into the processing system, or converted to magnetic tape, the primary means for the input and output of data. Magnetic tape gives data life at electronic speeds. Processing is done by the central processing unit, which makes decisions, controls the execution of instructions, and digests great masses of data at fantastic speeds. Output of essential results may be written on magnetic tape as readily processable and complete permanent records. Each reel of tape may contain millions of characters. Many results need to be in the form of punched unit records. The card punch produces these. Printed output is provided by line printers in the form of accounting documents and timely and concise management reports. The control console may be used as a monitor. It provides a means of communication between the system and the operator. The heart of the system is the central processing unit, into which has been built the machine's logical and arithmetic components and memory. Superior logical design makes the machine versatile and easy to use. Processing may be facilitated by magnetic drums, each of which vastly increases the system's memory capacity. High-speed memory can be the versatile and highly successful electrostatic type available in the 702. Or magnetic core, the most efficient electronic storage yet developed, as used in the 705. Magnetic core memory is composed of many thousands of ferrite donuts strung on fine wire to form one plane or matrix. Each core represents 1 or 0 according to its magnetic state. A small current sent along intersecting wires tests the magnetic state of a core, determining whether it contains a 1 or a 0. Each of 4,000 cores in each of 7 planes comprising a memory section contains 1 bit of a 7-bit structure. For instance, this structure decodes as the letter A. This one is the numeral 6, and so on. Magnetic core memory is made up of a series of these sections. Data stored here is available for processing in a few millionths of a second. Tremendous processing speeds require fast input and output. Tape units could read 10 average novels and simultaneously write them back on tape again in approximately 5 minutes. Commercial EDPM is equipped with variable field length and variable record length because business records are seldom of uniform size. Business records are recorded on magnetic tape with a density of hundreds of characters to the inch. Complete records are composed of elements of variable sizes called fields. Fields of a record might be part number, description, quantity, unit price, and so on. There is no need to fit information of variable size into compartments of fixed size as it is recorded. Variable field length and variable record length exactly fit information stored automatically, regardless of size, permitting data to be packed efficiently in memory or on tape. Some records require as few as 30 characters. Others run to many hundreds. There is no practical limit to the size of data recorded. Variable field length and variable record length mean fewer reels of tape, faster operation, more efficient use of memory. Frequently, business needs require printed results in volume. Printed output may be accelerated by the use of faster line printers. Here is an advanced model in action at 500 lines per minute. And for even faster output, a model that prints at the rate of 1,000 lines per minute. The volume input, volume output problems peculiar to business transactions are met and completely answered in this data processing system. A big, fast machine is of little use if it takes days to get source data to it. IBM has produced a series of machines to meet this problem. The first of these is the cardotype, which can prepare as many as 4 documents simultaneously in a semi-automatic operation from punched cards. It can produce a punched card record of transactions as a byproduct of any routine operation. The typewriter card punch also eliminates much source document handling, as well as manual key punching and verifying by automatically producing a card record as source documents are typed for the first time. The typewriter tape punch is similar in operation to the typewriter card punch, a compact punched tape record which can automatically be converted to IBM cards is made when documents are originated on the typewriter. The great speeds of data processing give new importance to data transmission? Here is the answer: the IBM transceiver, a card-to-card transmitter and receiver for fast, accurate, automatic transmission of data by telephone or by telegraph. A fundamental concept has been extended. Data is made self-perpetuating at its source, permitting rapid input for modern data processing and economical centralization of branch office records. The investment of American business in inventories alone is many billions of dollars. Inventory maintenance expense for record keeping and handling, obsolescence, insurance, storage, and taxes is extremely high. Inventories properly maintained mean dollar savings. Good control means increased production, better service to customers. Here is how a complete data processing system works. On centralized inventory control involving many materials and parts and many branches and warehouse locations. As we have seen, the bulk of input source data is automatically available as a byproduct of the preparation of daily transaction source documents. Here, the 824 typewriter card punch produces a transaction card as a requisition is typed. Transaction cards are forwarded directly to the central location or transmitted from distant branches or warehouses by the transceiver. Transaction cards from many sources are fed directly into the system in item number sequence, preceded by a small group of cards containing the machine's instructions for inventory control processing. Simultaneously, consolidated inventory record and requirements magnetic tapes go into action. These tape records contain every bit of information necessary for any required action, including current inventory status for each warehouse, plus combined overall status. A single processing operation swiftly records daily transactions, updates the many balances for each warehouse and in total, determines need for ordering, computes economical order quantity, tests for expediting, computes new order point. Complete new updated consolidated inventory records are recorded on tape. The card punch produces unit records for immediate action in the form of expediting cards and order cards. Operating directly from the system, the line printer isolates and highlights in a printed report those exceptional items requiring management action now to eliminate future emergencies. Volume printed output is achieved at 500 or 1,000 lines per minute by tape-operated high-speed printers. Here, an advanced model produces a part activity ledger. Similar operations will swiftly produce other printed requirements. Electronic data processing, when applied to inventory control in a complex manufacturing operation, means an improved inventory level, increased production, time and dollar savings, better service, and the timely knowledge of operations essential for good management. This is but one of the many areas where data processing provides a more direct line to decision. No phase has been neglected. From self-perpetuating source data and rapid data transmission, the handling of volume input and processing to volume output. A complete answer to the requirements of data processing. This answer from IBM laboratories is the result of years of development work in its various stages in basic research, component engineering, logical planning, machine design. Equally advanced manufacturing facilities are required to bring these concepts to reality. The world's most extensive production of electronic data processing machines is here at IBM Poughkeepsie, New York. Ideas for use are as vital as ideas for design. Their development is a continuing process. Across the country, representatives of American business and IBM have been working together, developing new techniques for the use of these newest and most powerful tools of management. But the real frontier of data processing is in business and industry everywhere. Timely knowledge, a firm foundation for wise decision, is isolated for action, revealing opportunities for new markets and new products, for reduced inventories and better scheduling, for better control, making American industry more efficient. Timely facts for decision are available to guide modern business in the management of resources, capital, and manpower, assuring continued growth in an ever-expanding economy by meeting with wisdom its first duty: to operate on sound business principles by establishing a direct line to decision.